Solving application problem using system of equations. So guideline for modeling system of equation. First, you read the problem very carefully and make sure all the words and idea are understood, and trying to start thinking what type of formula, what type of problem you are looking at, and what diagram can you draw. Identify what you're looking for. It's usually at the end of the problem, the last sentence where it's asking you to find something. Name what you are looking for and choose a variable to represent the quantity. You then translate into a system of equation. You solve, check your answer, and answer the question with a complete sentence. Alright, so let's take a look at the first problem. The sum of two numbers is 10. Okay, the sum of two numbers is 10. One number is 4 less than the others. Find the numbers. So the sum of two numbers. So we here what we're doing is we're trying to find that two number. So let the two number be x and y. Let x and y be the two number. So in the first sentence, it said the sum of two numbers is 10. This meant x plus y is equal to 10. The next one said one number is 4 less than the other. So let's say x is equal to y minus 4. Okay, x is the smaller number. Now we can solve the system of equation using substitution. I will substitute equation 2 into equation 1 to get y minus 4 plus y equal 10. Now that I get y equals 7, I can solve for x. And x equal to 7 minus 4, that is 3. So the two numbers are 3 and 4. Excuse me, are 3 and 7. So note that 3 plus 7 make 10, and 3 is 4 less than 7. In the next problem, Michael left the destroyer on the interstate driving south toward Orlando at a speed of 60 miles per hour. Clark left the destroyer 1 hour after, so later, traveling at the speed of 75 miles per hour, following the same route as Michelle. How long would it take for Clark to catch up to Michelle? So how long would it take? So this asking for the time. Okay, and for them to catch up would mean they have traveled the same distance. So this problem have to do with the formula distance equal rate times time. So let's go ahead and make a table of distance equal rate times time and see how we will work on it. We organize our information into the table. So distance equal rate times time. So let t be the time it takes for clock to catch up. So we know that the rate that take for Michael to travel is 60 miles per hour. And Clark is 75. Okay. So Michael left the story on the interstate driving south toward Orlando at the speed of 60 miles per hour. Clark left the story 1 hour later, which meant that Clark spent less time traveling than Michael. So which meant the time that it takes for Michael to travel before Clark catch up is t plus 1. And here's t. So the distance for Michael to travel is 60 times t plus 1. And for Clark is 75 times t. So here what we know is that they catch up to each other, which means they travel the same distance. This means 60 times t plus 1 is equal to 75t. And so we can solve for t here, and this is the one equation of one unknown and not a system. So here it takes 4 hours for Clark to catch up. Okay, so this is the review of modeling with equation using the distance equal rate times time. We use the same idea to try to solve the next problem. Okay. A river cruise ship sailed 60 miles downstream for 4 hours and then took 5 hours sailing upstream to return to the dock. Find the speed of the ship in still water and the speed of the river current. Okay, so I'll go ahead and let x be the speed of the ship. In still water. And y be the speed of the current. Okay. So let's create the table where we have distance equal rate times time. And we get going downstream and going up. Okay. So when we go downstream, we go with the current, which means we are going faster. So it is the speed of the boat plus the speed of the current. When we go back up, we go slower. So the speed of the boat minus the speed of the current. And we are told that the cruise ship sailed 60 miles downstream for 4 hours and upstream for 5. Okay. And we know that the distance here is 60. So here you can see we have two equations. 4 times x plus y equals 60. And 5 times x minus y is equal to 60. So let's go ahead and distribute this equation. 4x plus 4y equals 60. 5x minus 5y equal to 60, and I want to solve this equation. So to solve this equation, I first will simplify it. I'll go ahead and divide the first equation by 4 and the second equation by 5. So x plus y equals 15 and x minus y equals 12. And I solve this using elimination. I'll go ahead and add this together. So the speed of the boat is 13.5. Let's go ahead and solve for the speed of the current. So I know that 13.5 plus y equals 15. So y equals 1.5. So this telling us that the boat travel at the speed of 13.5 miles per hour. So the speed of the boat is 13.5 miles per hour, and the speed of the current is 1.5 miles per hour. Okay. We can also use this to solve mixture problem. Okay. Brandon is a lab assistant at his college. He needs to make 200 millimeters of a 40% solution of surface axis for an experiment. The lab only have 25% and 50% solution in the storeroom. How much should he mix of the 25% solution and 50% solution to make the 40% solution? Now, we don't know how much that he needs. We want to find how much that he needs, but we don't know yet. So we go ahead and let x and y be the amount of solution for the 25% and 50% solution respectively. Okay. So we have one thing, we mix with another thing, and we end up with something else. Okay, so we don't know how much of the 25%, and we don't know how much of the 50%. But what we want is 200 of the 40%. Okay, so 0.25 x, that is the amount of x's, 0.5 y, and this is 50. Okay, so here you have one equation, here you have the other. X plus y equal 200, and 0.25x plus 0.5y equal 50. I go ahead and solve this equation using substitution. I'll go ahead and solve for x in the first equation. I'll substitute the results into the second equation to get I'll go ahead and solve this equation. There's a typo over here. 40% of 200 is 80. So here's 80. And here's 80. Sorry about that. Okay, so we solve for y. So here we have 120 millimeter of the 50% solution. And 80 milliliter of the 25% solution. Let's take a look at the investment problem. Kayla have 40,000 to invest and she hopes to earn 7.1% interest per year. She will put some of the money in a stock fund that earns 8% a year and the rest into the bond that earns 3% per year. How much money should she invest into each account? So we noted that the amount of interest is equal to the principal multiplied with the interest rate. Okay, so let X and Y be the amount of money invested into the account respectively. Okay, so I go ahead and make the table. The amount of interest equal principal times the interest rate. And we have the stock fund and bond. So stock fund is X, bond is Y, and the interest is 0.08 and 0.03. Okay, so the amount of interest earned here is 0.08x, 0.03y, and the result is she hopes to earn 7.1% interest per year. So the total interest have to be 40,000 at 0.071. So 40,000 times 0.071. So here we have two equations. X plus Y equals 40,000. 0.08x plus 0.03y is equal 40,000 times 0.071, and that is 2,840. I will solve this equation using substitution. I've solved for x in equation 1. Substitute this result into second equation. Distribute. Divide. So this meant that she invests 7,200 into the bond that paid 3% interest per year. and the rest is into the 8% interest.